In this video for our Mach 3 review, I am only going over numbers 1 through 20, so just that first half. The first couple of questions were about the characteristics of our polynomial graph. So here I'm going to notice the ends of my graph here. So I notice that if they're going opposite directions that I have an odd graph. So not even, but odd. I also notice reading it left to right that this is going up. So my leading coefficient needs to be positive, not negative. So it's not A or D. Then here again, as x's are approaching positive infinity, the y values, or f of x, are now approaching negative infinity. So as my x's are approaching positive infinity, as we're going to the right side, well, what direction is our graph going? Well, it's going up towards positive, not negative. So let's check to make sure that our answer here is C. So as x values approach negative infinity, our f of x or y values approach negative infinity. So let's check it. Here, as the x's are going to the left towards negative infinity, on that left side, notice how our graph is going down to negative infinity. So yes, the answer is C. Then here, same thing. I'm going to have my ends here. So I'm going to create that and then identify the characteristics. So I notice here with going a 1 to 1 that my degree is odd. The leading coefficient, if I read it left to right, is going down. So my leading coefficient is negative. Now, as x's are approaching positive infinity, my graph is going down to negative infinity, my f of x values. As my x values are approaching negative infinity, notice here on the left, our f of x, our y values, are approaching positive infinity. Now, the roots and multiplicity. So the roots here, I actually only have 2 roots. So these 2 roots here are x is equal to -2 with a multiplicity. We'll notice that this is a bounce, right? So it has a multiplicity of 2. Then I also have my x and our root at 1. Now notice how it is a bend. It's bending through it. So with that bend or with that slide here, that has a multiplicity of 3. So if I were to write my equation in factored form, remember now factored, we're going the other direction. So I'm going to change the sign. So not -2, but +2. So x plus 2 with my multiplicity, so to the second power. Then x minus 1, right, for positive, but now with a multiplicity of 3, now to the third power. So question number 3, you're given a polynomial here that has a degree of 7. So which equation will represent in factored form? Well, I notice here that I've got x at 0. So I have x is equal to 0 with a multiplicity of, well, notice how that is a bounce. So the multiplicity is 2. Then I have another x at 1. So x is equal to 1 with a multiplicity. Well, notice how this is sliding through 1, so a multiplicity of 3. Then we also have a third one, x is equal to 4. And notice how this is also bouncing right off of it, showing a multiplicity as well of 2. So that means here all 3 of our roots have an exponent. So I'm going to mark off A because see how here it's saying that this has an exponent of 1. So I'm going to mark off A as well as D. Because again, if it's by itself, it's saying I have an exponent of 1. So it's got to be B or C. Well, remember here, if it's x is 0, then that is the same as saying x squared. So we're good on that part. Then here, instead of saying +1, right, make sure to change the sign. So that's why it's -1. So let's make sure that our answer is C. Then here we need x minus 4 raised to the second power. So notice how multiplicities work, and that's why the answer is C. So question number 4 here, sorry. here when g of x, a polynomial, is divided by x plus 4, the remainder is 0. So that means here that x plus 4 is a factor. Given that this polynomial here is our polynomial, which conclusion about g of x is true? Well, I can mark off C because it says x minus 4 is a factor, but we know x plus 4. Technically, we can make a conclusion about this because we have enough information to say that this polynomial divided by x plus 4 gives me a remainder of 0. Now here, if I were to plug in my factor here, so here we also have to understand that if we were to divide this, so like let's say here, if I were to use synthetic division, and if I were to divide this, right, and we set up our coefficient, we get that remainder of 0. What did we always use? Well, we didn't use positive 4 when we did the division. We used negative 4. So this one is tricky because people would want to say A. If you're dividing here, we're checking to see that negative 4 is the solution. Here, that would give you that remainder of 0. So that's why here the answer is D. Now, question number 5. What is the remainder when P of x, so this graph here is P of x, is divided by x plus 4, which again is represented by x is equal to negative 4. So here, notice how x is equal to negative 4 is a root. It's a 0. It is a factor. So again, with x plus 4, x is equal to negative 4 being a factor, that means the remainder has to be 0. So now question number 6. Which of the graphs in number 6 represents this situation that Isaac has? So he sketched a polynomial with 3 real zeros. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So far, so good. And it has an end behavior that describes as x approaches positive infinity, g of x, or we're used to saying f of x, so all the same, approaches negative infinity. So as x approaches positive, g of x approaches negative. So as x approaches positive infinity, is the end approaching negative? Yes. Here, as x approaches positive infinity, is our graph approaching negative? No, it's approaching positive. So then here, as x approaches positive, our graph is going positive, not negative. Then here, as x approaches positive infinity, my x approaches negative infinity. So now we've got to decide, all right, is our answer A or B? So now I'm going to go back to the key here, total of 3 real zeros. Well, remember now, yes, I have 1, 2, 3, but each of these have a multiplicity of 1 because it's a slice, slice, slice. So that shows I have 3. But notice here we have a bounce, which is 2, slice, which is 1, slice, which is 1. So really, this actually has 4 total real zeros. So that's why the answer here is A. Now with question number 7, the question is asking, what is the remainder when you divide this polynomial here by x minus 2? So here you're actually dividing, but we now need to see what is the remainder. Because I'm dividing by where x is by itself, right, coefficient and exponent of 1, we can use synthetic division for this problem. So instead of putting negative 2, I'm going to put positive 2 here, because that's what x would be equal to. Notice how we do not need 0, no missing terms. So I'm going to set up my coefficient 4, negative 5, 3, and negative 1. Bring down the first term, then multiply below the line. 2 times 4 is 8, plus that negative 5, which is 3. Remember, we're going to add above. Then multiply again. 2 times 3 is 6. 3 plus 6 is 9. 2 times 9 is 18. Plus that -1 is 17. So that's why here the answer was D. So now getting into some Mach 1 questions. This is going back to here if I'm looking for the value of B. Well, I first noticed that I'm subtracting. So I'm going to first distribute so I can see exactly what my equation is equal to. So in this case, we do have -5 plus 2i minus 5 plus bi is equal to -10 plus 3i. So now if I'm looking for the value of b, well, notice how b is imaginary, right? Because it has the I. So here, if I'm solving for b, which is imaginary, I only need imaginary parts. So notice how I have a positive 2i. So I don't need the -5s here because they're real. Then what's imaginary on this side here? Just 3i. So 2i plus what I is equal to 3i? 1i. So that's why here the answer is C1. So now here it's asking for the roots. Well, the roots is the same as asking for what x is equal to, right? The x-intercepts, the solution. We are solving for x here. So that means I need to first distribute my x. Well, and some people kind of get thrown off here, so I'll reverse it. So this is x squared minus 18x is equal to -90. Then in order to solve, right, it has to equal 0. So I'm going to add 90 to both sides of the equation. Now I've got x squared minus 18x plus 90 is equal to 0. Well, now I'm going to go ahead and check and see. Well, 10 times 9 is 90, but they would add to give me, well, if I had both negative, that would actually give me -19, not -18. I could do 45 and 2, 30 and 3, but really here, there is no factors that multiply to get you 90 and add to get you -18. I'm going to go ahead and start quadratic formula, which here x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a, where again, here I'm going to start with a discriminant. So here's a, b, and c. So I've got b squared, which is -18 plus, I'm sorry, as I put a plus, oh my goodness gracious, sorry about that, y'all, minus 4 times a, which is 1, times c, which is 90. Oh my goodness. So now when you simplify here, you will get a discriminant of -36. Oh, I just realized, guys, there's a little bit of a typo here. Answer choice C is missing the 9. But here I have a discriminant of -36. So that means with a negative discriminant that I have two imaginary solutions. So I need I in my answer. So I'm going to mark off A and C. So now I'm going to continue solving for x. So x is equal to -b, which is -18, plus or minus the square root of -36 all over 2 times a, which is 1. Now when I simplify, two negatives make a positive. So now I've got 18 plus or minus. Well, the square root of -36 is a perfect square. So here, 6i over 2 times 1, which is 2. Then notice here, we can simplify and divide all three values. 18 divided by 2 is 9, plus or minus 6 divided by 2 is 3. So 9 plus or minus 3i, they just separated it. So the answer here is B. With question number 10, you're just simplifying, but I do notice before I start combining like terms that we need to distribute an I here. So I'm going to bring down my I plus 3, but now I times 2i is 2i squared. then I times negative 4 is negative 4i. Now, before I continue, I notice I have 2i squared. I squared is negative 1. So really, I've got I plus 3, but now that is a negative 2 because that's 2 times negative 1 minus 4i. Now I can combine 3 minus 2, 1, and then I minus 4i, negative 3i. So that's why here the answer is D. Question number 11. This is that special case. So I know that I am multiplying 9 plus 3i to itself because it's raised to the second power, which is the same as 9 plus 3i times itself, 9 plus 3i. So now I'm going to set up the box here. So now I've got 9 plus 3i times 9 plus 3i. So here I've got 81, 27i, 27i, and 9i squared. So now here, I notice I've got I squared, right? Which is negative 1. So this is not a positive 9 anymore, right? But a negative 9 from that negative 1. Then combine like terms. 27 plus 27 is 54i. I also have 81 minus 9, which is 72. So that's why here with 72 plus 54i, the answer is D. So now question number 12. You're given this complex number here, negative 4 plus 32i. But which of these expressions would give you that same thing? So like for example, I could distribute this negative 1 here. So I've got negative 6 plus 44i minus 2 plus 12i. So now I've got negative 2 minus 2, which is negative 8. But I need negative 4. So I know A is not an answer. Here I'm distributing an I. I times 4i, 4i squared. I times 32, 32i. Now notice that I've got this 4i squared here, and I squared is negative 1. 4 times negative 1 is negative 4 plus 32i. So far, I've got B as my answer. Then C. So again, this is a box method because this is the same as negative 2 plus 16i times itself, negative 2 plus 16i. So here I'm going to set up the box, or you could do FOIL, negative 2 plus 16i times negative 2 plus 16i. This is positive 4, negative 32i, negative 32i, and then 256i squared. So I can already tell before even combining and solving with the value of 256 here, I do not have negative 4 plus 32i. So C is not an answer. Now D is just a good old multiplying two complex numbers. So I can set up and do FOIL, or you can do box here. So I'm going to go ahead and erase this. Oops. Let's try that again. Sorry, let me erase that. So now I'm going to go ahead and erase this here and then set up my box here. So negative 2 minus 4i and negative 6 minus 4i here as well. So now I've got positive 12, positive 24i, positive 8i, and positive 16i squared. Now notice here again, I've got another I squared, which would make this not positive 16, but negative 16. So if I were to combine 12 minus 16 here is negative 4. Then here combine 24i plus 8i is 32i. So I know that D is also an answer. Now notice the difference between here. So if the negative is on the outside, then that actually gives me a negative answer. So the square root of 16 is 4. So that's negative 4. Then plus Now, because that is a square root of a negative value, I know I need I. So that is 8I, but times 4. 8 times 4 is 32I. So -4 plus 32I. And so my answer is also E. So now with question number 13, here you are multiplying all of the front coefficients. So here that gives you a positive 168. Then remember, when multiplying, you now need to not multiply the exponents, but add the exponents. So now you're going to end up with 17. Now we use our quarter method and divide by 4. So now when you divide by 4, you get 4.25, which is 1/4. So this is 168, but then I to the first power because you had 1/4. Then I to the first power is just I. 168 times I, 168I, which is why the answer is D. Now question 14, I'm going to rewrite this here, but notice how this is saying that if I'm solving this equation and this is equal to 0, then this is, I'll also switch it, 19x squared plus 152 is equal to 0. Notice you have only two terms. I'm going to treat it like a two-step and then use square root at the end. So subtract 152 from both sides of the equation. So now when you subtract here, I've got 19x squared is now equal to, that is a negative 152. Now you can't take the square root yet, right? Because you're multiplying that x by 19. So now I need to divide both sides by 19. And now I've got x squared is equal to -8. Now take the square root. Notice how you're taking the square root of a negative value, and that's just 8. Square root of 8 can be simplified to the square root of 4 and 2, which here the square root of 4 is 2. But because remember, right, this had the square root of -1, which is I. So 2I radical 2. That's why here the answer is A. Question 15. And again, here we are solving for x. But right now it's equal to 8x minus 1, but we need it to equal 0. So I'm going to do two steps here. I need to subtract the 8x, which I'm going to line up with my like terms. And then I also need to add 1. Now I've got 0 and nothing to combine that 7x squared with, so bring it down. 7x squared minus 23x from -15 minus 8 and plus 6 from 5 plus 1. Now we can solve, but I cannot do the table yet because of my 7 here, that leading coefficient. No GCF, so I'm going to go right into bottoms up, where now I've got x squared minus 23x plus 42 is equal to 0. Now we can factor. What numbers multiply to get you 42 and add to get you -23? -21 and -2. But am I done? No, because remember, whatever you multiply by that A value, now divide by that A value. So I've got x minus 3 and then bottom up. 7x minus 2 is equal to 0. And because we're solving equal to 0, change the signs. So now this is not -3, but +3. Then I notice from my answer choices, my answer here is B. But I can also see in using my shortcut, right, that if I've got -2 sevens here from bottoms up, I need +2/7. Question 16. Now, notice how the power is outside of the parentheses. So I cannot add 8 yet because of my exponent. I need to first take the square root. So now that exponent is gone. and I've got x minus 8 is equal to the square root of negative 25. So I know because I've got the square root of negative 1 here, that I need I. So that's why here I've got plus or minus 5i. Then now add 8 to both sides. But can I combine 8 and 5? No, because they're not like terms. That's why the answer is C. Then question 17. Here we have negative 5 being raised to the third power. Negative 5 to the third power is negative 125. And I is not by itself because it's also being raised to the third power. So I to the third power. Well, I to the third power is negative I. Negative 125 times negative I, negative times a negative is a positive 125I. Number 18. Which equation has two imaginary solutions? That means if you're looking for the number of solutions, you have b squared minus 4ac. All you need is the discriminant, and it has to be negative for two imaginary. So here's a, b, and c. So here we go. B squared, negative 2 squared, minus 4 times 3 times negative 5. So now I've got 4 plus 60. Well, that's going to give me a positive answer. So I know with 64, my answer is not A. So now let's go to B. A, B, C. So again, B squared, negative 3 squared, minus 4 times A, which is 4, times C, which is 3. Now here, now I've got, when you put all this in the calculator, because this could give you 9 minus 48. Notice how if you were to subtract that, you do get a negative 39. So that's why here the answer is B. Now, of course, you can still go through and see that this is my A, B, and C. B squared, so 12 squared, minus 4 times A, which is 4, times C, which is 9. Here you have 144 minus 144, which is 0. That is one real solution. And B, again, A, B, and C here. So here I've got B squared, so 5 squared minus 4 times A, which is 6, times C, which is negative 6. Then when you put all that in the calculator, you also get a positive like we got for A. So that's why the answer is not D. So here, remember, for imaginary solutions to imaginary, the discriminant has to be negative. Number 19, this is asking for which of the representations has complex roots. Complex, remember guys, complex numbers, so we're talking about the imaginary, not real. We're looking for imaginary. What would have I in its final answer? So like for example, I notice here for A, to solve for X, I need to first divide by 2. So now I've got here, x plus 3 to the second power is equal to 32. Then take the square root. Well, I'm taking the square root of a positive value. So really, do I end up getting an imaginary solution? No, I'm going to end up getting a radical, but it's still positive and real. My answer is not A. Here, I'm going to subtract 33 from both sides because it's a two-step, missing an x term. Now I've got 9x squared is equal to negative 33. Then divide both sides by 9. Now I cannot divide that evenly, so I'm going to keep it as this fraction, this negative fraction. Then take the square root. Now notice even though it's a fraction, notice how I'm taking the square root of a negative value. And what did that mean? We had the square root of negative 1, which is I. So that's why the answer here is B. Now, if you're wondering, because I know some people said D, the reason why it's not D here or C, you can graph C, but the reason why it's not D is because notice how it has actually one real solution. X is equal to 2, and that is real, not imaginary. So here, 20. What are the solutions to this equation? Well, I cannot multiply two factors to get me 5, positive 5, and add to get me negative 4. So again, this is quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Then I'm going to first look for my discriminant. So b squared, so I'm going to identify my a, b, and c. B squared negative 4 squared minus 4 times a, which is 1, times c, which is 5. Now here you get a discriminant of negative 4. So that is your discriminant. That means I need I in my answer. So I'm going to mark off E and F because those are whole numbers when I need I. Now I'm going to continue. X is equal to negative b, well, b is negative 4, plus or minus the square root of the discriminant, negative 4, over 2 times a, which is 1. Now notice in the numerator, two negatives making a positive. So I've got 4 plus or minus. Well, that here is the square root of negative 4, which is 2i, all divided by 2 times 1, which is 2. Then notice I can divide. So here I've got 4 divided by 2, which is 2, plus or minus I. So if I wanted to see what my answers are, that is the same as 2 plus I and 2 minus I. So that's why here the answers are both A and B.